Hello students, good day to all. Welcome to the Unit 1 lecture. In this video, we are going to see about the electric field intensity due to the surface charge density. Consider a surface charge density rho s, which is going to be spread on the xy axis. So this particular surface charge density is going to be spread on the xy plane, both on the positive and the negative plane. And also you can notice that this rho s has been spread on the xy plane as the symmetric as that of symmetrical one. So what do you mean by symmetry? If you are measuring any distance from the surface charge from the origin, means you will be getting the same value wherever you measure on the surface charge. So this surface charge distribution is going to be called as rho s. Then this rho s into ds, integration of rho s into ds, is going to be surface charge density. Means what are all the unit vectors that are going to constitute on this ds. Means since this is being spread on the xy plane, the particular unit vector which is coming out of this particular surface is going to be on the z-axis, because this is spread on the xy plane. So if you are making the perpendicular vector from this particular surface, means that is going to be constituted on the z-axis only. Since this is going to be on the z-axis, then the surface is going to be constituted with the help of rho and phi if it is going to be cylindrical coordinate system. So the ds vector is going to be constituted with the help of d rho and the d phi. So since it is going to be constituted only with the rho and phi, so we will be having the term as the rho into d rho into d phi. Why? Because the d rho is going to be held with the arc length of the particular change in the rho. So that particular arc length is going to be called as rho into d phi, and the change in the rho is going to be called as d rho. So we will be getting the surface charge as the rho into d phi into d rho. So if you are substituting the ds vector with the help of these particular terms, that is rho into d phi into d rho, means rho s into rho into d phi d rho will be coming. So electric field intensity at any point by a seat of charge, means this d vector is equal to dq divided by 4 pi epsilon naught r square ar cap. So from the figure, if I am having r vector from this particular piece, and from this particular piece we will be having the distance as the rho r vector. So this r vector is going to be measured as this, that is rho into minus of a rho cap plus z into a z cap. Why it is going to be minus? Means just notice this particular diagram. In this sheet of charge, you are going to constitute two different points that are all in the one point is on the plus xy plane, another one point on the minus xy plane. So if you are making the particular distance vector from these 2 points, means these 2 points are going to be travel in the direction of minus rho. If you are going to consider a cylinder, then if you are measuring that particular vector from the periphery of that particular cylinder into the center of the cylinder, means then the vector is going to be considered as a minus a rho only. Why? Because it is traveling on the opposite direction of the row vector. So row vector will be coming from the center point to the periphery of the cylinder. That is only going to be called as row vector. But this particular r vector is going to travel on the opposite direction of the row vector. That's why we are going to say this is the minus a row cap, and since this is the distance of row into a minus a row cap plus h. Why h? Because we are going to measure the distance from the origin to the P point. So we are going to measure this particular distance as h. So h into a z cap, since this is on the z axis. So we can say the r vector as the minus rho into a row cap plus h into a z cap. So the r vector is going to be constituted as the magnitude of the r vector is equal to root of rho square plus h square. So if you are going to measure the ar cap, the unit vector, r vector divided by magnitude of the r vector, so we can write that is minus rho a row plus h into a z divided by root of this particular rho square plus h square. So if you are substituting the 1 and 2 values on the second equation, then we will be getting the equation like this. Since the surface charge is going to be a symmetrical one, so due to the symmetrical nature of the surface charge on the positive and the negative axis of the xy plane, a row component for the 1 and 2 means the elements 1 and 2 on the surface charge, 1 and 2 element cancels each other. Why cancels each other? Because this particular component is going to be on the plus xy plane, this is on the minus xy plane. Since the vectors are on the positive and the negative surfaces of the xy plane, the electric field which are going to be constituted by these two particular charge density parts are going to be having the rho component as the same components with the negative values. So this is going to be the half of the charge density, and this is going to constitute another half of the charge density. Since these two are on the rho plane, rho vector, they are going to constitute on the rho vector. Since they are going to constitute on the rho vector, but they are all in the different directions, that are that two opposite directions. So the both rho component are going to be cancel each other, and only z component is going to be constituted. So what will be this term? Minus rho into a row cap will be going to be 0. So only h into a z cap is going to constitute. So dE vector is equal to rho s rho h d phi d rho into a z cap divided by 4 pi epsilon naught root of rho square plus h square power 3 by 2 will be coming. Since we are having only rho and the phi differential terms here, so our integration will be having the surface integral only. So we are going to take the surface integral for the rho and the phi. So what are the limits for the rho and phi? For the phi, the limit is going to be from 0 to 2 pi, and for the rho it is going to be 0 to infinity. So if you are substituting these values and making this denominator term into the numerator, so we will be having rho square plus h square power 3 minus 3 by 2 d rho d phi a z cap. This rho s by 4 pi epsilon naught will be as such. Making this particular constant terms outside, rho s h divided by 4 pi epsilon naught. It will be coming. Now we are going to integrate this d phi. So since here no phi terms, so we will be integrating this d phi term and applying this limits. We will be having 2 pi minus 0. So this particular integral has been calculated as 2 pi. So we can cut these two values as the rho s h divided by 2 epsilon naught. So this term is going to be finished off. Now see, here rho is here, and here is also a term. So rho square plus h square power minus 3 by 2, it will be coming. Here rho term is on the aloof, that is it is separate, and this term is also separate. But integrating this particular power term is going to be tougher one. So what we are going to do is, we are going to make this d rho as a d of rho square. So if you are making this d rho as a d of rho square, we will be having two additional terms. That is, rho is one additional term, and another term is going to be 1 by 2, because if you are making this particular differentiation, we will be having 2 into rho into d rho. It will be coming. So rho is already is here, so we can make that particular rho as into this particular term, and 1 by 2 is the extra term which is going to come. So we can write this as a 1 by 2 d of rho square, as such we can write. So how I get write down? Just notice that is d rho. I am going to make this as a d of rho square, means I need to have extra terms. That is, if you are making the if you are going to make this term, means you have to replace this term with this term. So extra term you have to be with 2 into rho into d rho should come, right? So extra term is this 2 is the extra term, and this rho is already here. So this extra term is going to be compensated by the 1 by 2. That's why we are getting this 1 by 2 d rho square. Okay, now listen. So this rho s h divided by 4 epsilon naught, we have make the arrangements for this particular equation, and just to integrate this term, since we are going to integrate for the rho square, we will be having this as a single term, and minus 3 by 2 is going to be integrated as the minus 3 by 2 plus 1. So this term rho square plus h square power minus 3 by 2 plus 1 means it will be coming as minus 1 by 2. How? That is minus 3 by 2 plus 1 means, so minus 3 plus 2 divided by 2. So this term is going to be coming as minus 1 by 2. Okay. So if it is going to be the case, then we will be having rho square plus h square power minus 1 by 2 divided by minus 1 by 2. Integration limits are 0 to infinity. So if it is going to be minus 1 by 2, then we can take the minus rho s h divided by 4 epsilon naught 2 divided by root of this rho square plus h square. So if you are going to apply these limits, we will be getting this as infinity. If you are applying, then anything divided by infinity is going to come as 0. Okay, so 0 minus if you are going to apply the 0, then this term is going to be 0 and 2 is there, and if you are having a root. So if I'm making this 2 as the 2 as going to come out, then this is 2 divided by this is h square, because this term is going to be 0 because we are applying the 0 limit. So this is going to be 0 root of h square, then it is coming as 1 divided by h. So this term can be cutted out. So this 2 is cutted out, and answer will be 2. So minus rho s h divided by 2 epsilon naught. So this h and this h is going to be cutted. Then our equation is going to come as rho s divided by 2 epsilon naught. Thank you.